My name is Mark Stahl. I'm an engineer here at Google. I actually was a graduate Carnegie Mellon. So are there anyone from Carnegie Mellon? Yes. Yes. Hi, Mark. Hi. So there's more than one of us here. I saw several CMU people, so I'm really happy for that. I'm the tech lead on the GData APIs team. So we build a lot of the APIs for Google products. Google has a lot of services. We have a lot of data, and we have a lot of problems one of our problems, making data universally accessible. So one of the missions of the GData API team is to make it universally accessible and also easily accessible. So my co-presenter here is Jeff. So Jeff works in university relations. You want to say hi?
Well, actually, I work in developer relations.
Relations.
One of the things we relate with is developers still earning their degree. So.
So he actually helps a lot of people use the products that my team helps build. And so how many people are familiar with the Google Data APIs already? How many people actually use them? So how many people know, well, Pamela, she's also in developer relations, so of course she's used them. How many people have used like RSS, Atom feeds? Are you guys familiar with RSS and Atom for receiving data? Okay, let's go something simpler, XML. How many people use XML or know XML? Yeah, okay, now we're getting some groundswell. And HTTP, how many people know HTTP? Right. So it's good. So there's a technology base on which we're going to build, and everybody knows that one. This is an informal presentation. If you guys want to ask questions, feel free, jump in, raise hands. Yes?
Okay, I for once am not 100% sure what Google data exactly means, so I might have used some of this and not know that it's Google data.
So you want to know like a concept
like
of
a very global, like what are we actually talking
Well,
about?
Google Data APIs. Oh, you've got a microphone. Google Data APIs, actually, if you go to the next slide, I'll just say a little. In fact, I think I start. Oh, I go to the next slide. Oh, cool. This is my first time with a clicker. So one of the things that we're talking about here is Google has data. So we have calendar data, we have spreadsheet data, we have bloggers, but what I'm talking about the data is not just the web stuff that we have. I'm talking more about there are personal data sets that everybody maintains at Google. This is there are many little tiny sets of data that people have. If you've used Google Applications, which is one of the primary deployment areas right now for Google Data APIs, you keep a lot of your data at Google. If you're an administrator of a domain, you have data on you have a lot of data you need to manage at Google of who are all your users. You have a lot of blog posts you're creating. You have a lot of calendar events that you're managing. You have the set of calendars that you're subscribed to that you're managing. And so you have a lot of data, and one of the things that Google's trying to do in making data accessible is not just creating these really cool web apps. So web applications are all about your personal data and sharing it and making it available. But UIs are great for humans, but they're really bad for programmers. So one of the things that we want to solve is that you're sharing your data sets, a lot of little data sets, you're sharing them on the web. So we talked about some of the properties here. Does that give you an idea, the type of thing we're talking about? So one of the things we talked about here was I was just sort of trying to outline a little bit of the problem case that Google Data APIs, which are actually built on a protocol called Atom Publishing Protocol, which I'll use a lot. And one of the things that some of the properties we're trying to encourage. So I say here, structured data. So obviously, of course, you could basically just dump blobs of text on the web. You could do CSV files. There's all sorts of simple ways to structure data so that computers can consume it. Discoverable, I mean, how do you find this data on the web? How do you access it? Cacheable, this is one of the things that Google deals with a lot is scale. So if 1 million people are accessing your data, being able to cache it is extremely important, or being able to take advantage of ways of performance are important. And then, of course, just standard-based protocols. One of the things that this is about universal accessibility. If we build our APIs on very common, well-accepted standards that then anybody can access this data. Anybody can build programs to interact with it. So another part of data, like all these data sets that I'm talking about, these application data sets, you want to be able to edit the data on the web. So if you're, say, for your calendar, you want to be able to modify your calendar and actually synchronize with your calendar applications. You want to be able to modify your photos. You want to be able to upload videos and search videos and do all these other types of things that you're going to want to create blogger posts, all sorts of things. And finally, then, one of the other goals that we have is that we're trying to really make our APIs extremely user-friendly. Google is about trying to make stuff universally accessible, which means not just the programmers who have a company that will pay them a year to read every specification on some particular access technology, but they can pick it up overnight. It's very familiar, simple technologies that they can learn quickly. So I just sort of looked at a little bit of suggestion here of some of the type of technologies, to sort of give this a little bit of a context. Some of the technologies we're looking at and how the Google Data APIs sort of fit into this. So HTML, think about HTML as a way to share data. I mean, you probably all think of HTML as a presentation protocol and for papers. But think of it as a way to share data. You can put tables up. Anybody in the world can get them. They're extremely discoverable. They're search engines. They're simple. They're extremely usable. I could probably teach my mother to write HTML tables. It's not that hard. And there's really no tooling required, so we really win on user friendliness. We win on standards based, but it has absolutely almost no structure. It has no editability, at least not in standard. There are some things with wikis, but again, they're completely non-standard editability. But if you want to just share your data, HTML is actually quite good. You may have never thought of it as a data sharing protocol, but it's actually pretty good. So if you think of other ways of doing things on the web, another extreme sort of, another end of it would be sort of like SOAP. SOAP is a standards-based XML model of doing RPC. So now you've immediately got this idea you can exchange arbitrarily complex structured data. It does any arbitrary RPC. It has sort of a discoverability issue. So if you've got a data set that you want to make available to other people, you publish what is the definition language for SOAP? I can't remember. The WSDL.
WSDL, yeah.
You publish your WSDL. And so anybody can read that WSDL, construct an interface, and start accessing that data. They can do any operations. They can certainly do CRUD, basic CRUD operations on your data, but they can do any other arbitrary transformations. But however, it's basically just arbitrary RPC. There's the user friendliness level of it sort of goes down. There's been a lot of problems with interoperability among SOAP implementations. And you definitely are dependent on the tool chain that builds your SOAP. So your weekend programmer isn't going to necessarily pick this up. It's not going to be something that I will pick up in an afternoon. And as I say, it's standards-based. As someone said, I put 2 stars there because, as someone said, the nice thing about standards is there are so many. And SOAP is, I think, known for having large numbers of standards. So in the last 5 years, there's been a trend towards a style of architecture that they call REST. Have anybody here heard of the REST architectures? So REST is a whole philosophy of building APIs. So it's a little bit difficult to summarize real quickly, but essentially the idea is you think of your APIs as resources, and that's what the R in REST is. Resource, representational state transfer, and the representation is of a resource, excuse me. So R is representation. And REST model is basically based on sort of like the REST model is like the HTML model, but for data. So the idea is HTML objects, pages, are resources that you fetch and view. REST objects are resources that you fetch and manipulate. And they're all addressed by HTML. They're all addressed by URLs. Every resource has a URL. Every resource is a document containing a certain amount of information in it. And the protocol for manipulating your resources is the same protocol that the web uses. It's HTTP. It's CRUD. It's, you've got your get, you've got your post, put, you've got delete, you've got your basic CRUD operations on these data objects. And that's really how REST is very simple. And what you get from this is the format of a REST document can be anything. We typically use XML. So already it's going to be structured. It's relatively simple as XML can be for the average user. It certainly has the model of discoverability. All your resources exist as URLs. And you can actually include in your resources links to other resources so that you have the ability to be discoverable. Because you're built on the HTTP infrastructure, the protocol infrastructure, you get this great benefit of cacheability. So if 2 people fetch the same resource, there's a proxy. Suddenly this resource is cacheable. you have cache coherency protocols that HTTP has worked out, such as using, if you're familiar with entity tags, which is a way of tagging a resource with a strong version so that you can validate that the resource hasn't changed without actually transferring it twice. So these are the types of things that REST architectures give you. And again, it's so simple, no tools required. AtomPub is an implementation or sort of an embodiment of this REST philosophy. And what they've done is they've taken, well, actually, I'll go into a little bit more detail on AtomPub a little later, so I'll just sort of show you. But the idea is it is a REST-based protocol, but it is an implementation of a REST philosophy. Does everybody sort of get that? Because that's kind of a core philosophy behind the whole AtomPub way of doing things. So when you want to look at what is the Google Data APIs, the Google Data APIs are at their core, we are Atom Publishing Protocol, which is what AtomPub is. And Atom Publishing Protocol is a REST-style protocol that sort of defines two things. One is a wire format for transferring data, and that wire format is based on Atom syndication format. So I asked if people know RSS and Atom. Essentially, RSS and Atom are an XML format for transferring collections of information. And it's a fairly trivial system. And the protocol, I'll actually go in a little bit more detail. The protocol operations for Atom Publishing Protocol are all HTTP verbs. So what we've done with GData is we've started with Atom Publishing Protocol, and then we've added several extensions to how you're going to use Atom Publishing Protocol, essentially taking it from this theoretical construct that's good for reading and writing blogs to something that's much better suited for reading and writing data. And so we've actually extended the data model so you can model how we actually come up with patterns, design patterns, how to model more data and make it more available. We've added querying, we've added some basically concurrency issues and authentication, batch processing, basic things that we find that our consumers of these data sources really need. So Atom Publishing Protocol, one slide. There's only two data types in Atom Publishing Protocol, two basic data types in Atom Publishing Protocol, two main concepts. One is the concept of a feed. You always talk about RSS feeds and Atom feeds. And we use the word feed a lot, and it confuses people because everybody thinks, nobody knows what a feed is. It's this thing that shovels data at you. In our case, in Atom Publishing Protocol, a feed isn't something it's not a conveyor belt of data. It's just a container that you store data in on the web, and it exists out on the web. And it's addressed by a URL. It is itself a resource, is the feed resource. Within the feed, then there's another type of resource, which is the entry. And the entry is just any data item resource, and that data item is itself structured. And if you go read the Atom syndication format and the Atom Publishing Protocol spec, you'll just see the feed and entry is just, a feed is just a simple document. When you transfer the contents of a feed over the web, you're transferring an XML document, and the entries within it are just XML subdocuments within that. It's very straightforward. Most people can sort of look at one and understand what it is. And then the actual protocol is limited. It's CRUD, and this is about it. So we're using HTTP verbs insert, add an entry to a container, get the contents of the container, which is the feed document containing the entries. And then you can perform the basic CRUD operations on individual entries, and that's pretty much the whole protocol. It's very straightforward. So first thing I'm going to talk about a little bit about is what does one of these data entry items look like. So this is everybody's XML. As I told you, it's extremely easy to read, right? Everybody can read this? Yeah. So let me break it down a little bit for you. So if you think about what is a data item, this is an entry. If you notice, I have an entry field here. So this is an entry item, and essentially there's some content. This entry happens to represent a calendar event. So essentially there's content here. Atom provides a standard set of XML tags for representing content. Title, content. What is the content tag actually says what is the nature of the event. Author, there's several other standard features that XML offers for actually conveying data. One of the other nice properties of using Atom syndication format is every entry is required to contain a certain amount of metadata that makes that entry very self-describing and very useful. So extremely useful metadata like date and timestamps. When was it created? When was it last updated? These are required by the Atom Publishing Protocol, and they make it very easy to do synchronization and start getting the most recent changes to the information on the web. A universal ID, all items have to be tagged with a unique identifier. Again, in true web fashion, it's always a URL, which goes on forever. There seem to be an infinite number of them. And then, of course, you'll have things like links. I mentioned that you can always embed links. And this is a lot like HTTP, only in this case, the link represents a place where you operate on this link in order to edit this particular entry. So this is what some of the things that the Atom Publishing Protocol provides, Atom Format and Atom Publishing Protocol provides as representing data. So in GData, what we've done is we've taken this basic format and we've provided our own extensions to it. So we say when we're doing calendar events, we've defined our own XML for extending the data that's in this entry, so that essentially start time, end time, reminder, and so on. And also we've added a typing mechanism. So in this case, this category tag says, so consumers now, they see this entry, they know it's a calendar event, they know what schema it's going to conform to, and boom, they can actually start processing it. And people, this format is actually simple enough that people can process it. They can handwrite code to process it. HTTP processors are easy. XML processors are everywhere. And every language has one, and you can start building on it. So the basic protocol, again, as I said, is based on HTTP. And I'll give you a quick example of how to insert an entry into a container. So you'll see I have example.org/feed, very simple protocol. And I'm going to send an Atom entry to the server. And what I'm going to get back is an HTTP result, 201 created, standard HTTP return codes, no special contents, no special code in the body of the message itself. And what we're going to have here, this entry now is going to be modified by the server to provide, the server can assign a unique ID. It can assign links and tell you where you're going to go to edit this thing. It conveys all that information back. And from here, now that I've got an edit link to this entry, I can edit this entry in the future. I can also do a get operation on the feed and get a list of all the entries that exist in that entry. So it's a fairly straightforward, simple protocol, low barrier to entry for programmers. So querying, let's see, I think I actually was going to drop that slide. So querying is probably simple enough. Essentially, we've added a query model, and it's the simplest thing you could imagine. Essentially, you use URL query syntax. So here I'm doing a full text query on all. If you pass this to the feed URL, you pass a query, it will return you a feed document and all entries that contain that text. It's not particularly difficult. And we define whatever query parameters we find, whatever metadata query parameters or whatever we think are going to be most useful by the consumers of this data source. One of the things that we're very concerned about is authentication. Because we're dealing with your personal data, we have to deal with desktop applications. We have to deal with web applications. We have to deal with JavaScript applications. So we're forever trying to expand the suite of ways that you can authenticate and still maintain security. So how you share, how you do access control, all these things come along. Optimistic concurrency. We had originally created our own optimistic concurrency protocol by embedding in the edit links. We'd actually embedded a version number so we could detect conflicts. We're actually moving towards a newer version, which is this entity tags. These are standard HTTP mechanisms for conflict detection, and they are also standard HTTP mechanisms for caching. So this move is going to make us more standards compliant, which again means we're building on common libraries, and will improve our caching performance. Media entries, you can store binary data in the Atom Publishing Protocol. That's actually, and batching operations, you can make changes on multiple items. These are some of the types of extensions that we've worked on. We're actually working on extending the protocol based on the feedback of our users. So I think partial update and partial get are things that people have been wanting to modify one individual field in an entry and so on. So we're actually actively working on developing this protocol and moving these things into the standard space. So where do we actually do AtomPub APIs? This is the current list. It's growing every day. So when I mentioned that it was originally, Atom Publishing Protocol was originally designed for Blogger, but we're using it for calendar, web albums. YouTube is one of our most popular APIs, and Picasa web albums are one of our most popular APIs. Our health product is all built on GData. In fact, their whole UI actually is built on top of this GData API. And plus, it's all the interconnection with all the service providers is built on top of these GData APIs. And so on and so on and so on. And we're adding more. And I highlight these two because you'll see those a little bit later. And the other thing that we provide, as the GData API team, we help build GData APIs within Google, which are AtomPub APIs. We also provide a huge set of language toolkits for clients. So I said it's easy enough that people can connect, but we actually try to provide a higher level for people who want to actually interact with them in particular languages. These are all open source libraries. You can download and play and modify any one of them. And with them, you can connect to any of these services and get slightly higher level semantics for inserting entries, deleting entries, and so on. Because it's an open source protocol, the specification is simple enough. We've had people developing them in all sorts of languages. So I just mentioned that. And it doesn't even require a client library. A lot of people just subscribe with a feed reader. A lot of people use, we have a JSON output format, which a lot of people write JavaScript and are immediately fetching data, say the latest 5 blog posts, they fetch it, embed it in JavaScript format, embed it in their web page immediately. So there's almost half our usage, somewhere around half, I believe, is done without any of our client libraries. That's how easy that's how low the barrier to entry is for using for accessing your data. So that's a brief tour of all the GData effort at Google. Jeff's going to present some little application that we were trying to show some of the applications of GData, and he's going to do a quick presentation. Are there any questions on this stuff real quickly? So, okay, Jeff.
Okay, we'll give you plenty of time for questions again at the end. So the application that I'm going to show you is actually a game built by our own Pamela Fox, who's hiding right there. Okay. And so the idea of this game, let me introduce it to you first, is that a user is presented with a set of images, and they're supposed to munch, I guess, the ones that represent this keyword they're given. So they go through and they pick it, and if they pick the wrong one, they lose their life. And if this random guy who's coming after me eats me, the traggle, I'm sorry, you also die. And then you can progress to different levels and get high scores and all that sort of thing. And so it's, a cute time waster, but the the real point of this is a simple observation that I think many computer scientists have realized, that computers aren't very good at recognizing images, at least not compared to people. So you can design algorithms, you can train machines, but it takes a lot of time and effort and CPU power. But you can throw a simple little game up and people will waste their boss's time giving you a nice index of relevancy search. So what we would do here is we record every time someone clicks on an image, and then we decide that, well, if they clicked on it sooner rather than later, it's probably a better result because it's more recognizable, it pops out to them. So here's an example of things we've collected. On the left is the image that we pick based upon the highest score, and on the right is just doing a tag search for that image. So Apple, a little bit more relevant. Got baby there.
Do you want to mention what the data source is?
Yeah, I'm getting to that. Don't rush me. And then like line, really hard to find an image search for that, but people can visualize it very easily. So as the question that Pamela just asked is, well, where does Google come into this little mashup? I mean, you've used Flash, that's not even Google. This whole thing is hosted on App Engine, I'll mention off the bat, which is our application hosting environment where you can upload a bit of Python, it runs on our infrastructure. But how do the data APIs come into this? Well, the images are coming from Picasa Web Albums, so there's one API there. And I actually built a second piece into this. I think we have a slide to demonstrate all this. There we go. So we're pulling these images in from Picasa Web, and we have this App Engine backend. We have the front end that uses these images to run the game and display you some results. And all the data is stored in the App Engine backend. But now maybe you want to publish some of these results. So a trivial implementation here is to export to Blogger. And so if I show you that, create a really basic report generator that, if I make it log in again, I can get an access token for my Blogger blog. So I pick the blog, I generate a report. In this case, it's just the 25 top scored images. And here I open a nice draft, the HTML table of the data, and I can edit this. And then I can publish it to my research blog, and everyone can see, oh, great. what today are the top images. And you could also imagine exporting this to something like spreadsheets, which is very good at visualizing tabular data and setting up charts and setting up gadgets to visualize them and track differences over time, see what people are most interested in. And so that was a very simple integration using our Python client library. We were mentioning our client libraries earlier, to use the data API for Blogger and create that. And then the other component, which is showed at the bottom of this chart, is we've actually republished our database using an Atom format. So an arbitrary consumer of Atom can look at our data. So in this case, here's a feed representing results data for the tag Apple. But likewise, we could do line. And actually, if we go back to Apple for a second, you notice the second result is Steve Jobs. But so Firefox makes this pretty, and you can't really see all the metadata in here, but we do have XML describing, for example, the number of trials a given image has shown up in, its current score based upon how people clicked on it, and also the URL to the thumbnail that we're using for the image. So this is sort of a toy example with the toy data set, but you can imagine in your own research, you probably will collect gigabytes of data stored in some database. And right now, you could always, I guess, burn it to a DVD-R for a colleague and have them set up their own MySQL and do their own queries against it. But you could also consider exposing it as a RESTful web service like this, and people could query just for the slices of data they're interested in and create neat visualizations on what you've managed to gather. So that's sort of kind of the spirit of what we're trying to do here in terms of exposing data for collaboration and making it useful to not just whoever owns that data, whoever's storing that data. And of course, I have to show you some code to convince you that I'm not just making this up and it's not all magic smoke. So, for example, to integrate with Blogger, this is all Python. I don't know if all of you love Python or not. I do. But so we're just creating a Blogger service. We're getting this authentication token back from Authsub. And a lot of it really is as simple as creating a new blog post entry, setting some bits of metadata for it, and then submitting it to the service. So it's really not too bad. I mean, I did this in like 10 minutes. I spent more time trying to format the date than I did actually exporting to Blogger. And the nice thing about App Engine is it uses the Django template engine. So you can do things like create report things based upon data structures in Python very easily. And similarly, I was even able to create the entire Atom feed just using the simple template engine where I pass it data sets stored in template variables, and it just magically generates an entry for each photostat we have for whatever tag we're querying on. And so that's like a really, really super high-level view of what we're trying to do here with this application. But I think you can appreciate the greater message in that you can use our APIs either to collect data in the sense of you can grab images from Picasa Web, you can grab videos from YouTube, but you can also do things like build little applications on top of them with App Engine, and you can republish them to our applications you may be already using, like Blogger to do a research blog, or spreadsheets to visualize data and to keep track of it. And so I think that's everything for
and then that
my
last
bit.
one, which was just
just using
the last
our
one,
format.
which is, yeah, AtomPub is a publicly available format. It's IETF standard, and if you wish to republish data yourself, it becomes a way for other people to consume and build services
and
on
also
top
we
of
have,
the top of the data that you're collecting and the data that you're exposing. So.
We've opened GData format as well, so you can steal all of our semantics in our query language, and we won't go after you. And so that's very cool. So you want to go to the next slide here?
So, what we thought for the last part, so what we've given you an overview of what GData is and one sample example. So we were sort of hoping to have a little dialogue and get ideas from you. When you have this way of data formats, what are the types of things you can think of that would be useful to do? And how could you use it? How would you like to see us use it? What could we do for you to make your life easier? So I went down and I sort of tried to think of the types of things that we think of when we think of GData as this sort of big, and AtomPub as this sort of big area that can be used to do lots of things. One, of course, as we've shown you, is build applications. I mean, this is exactly what he did. He said, I'm going to build a novel application to do semantic classification of images, structuring it as a game, but I'm using all these data sources exposed to get data. I'm using this GData protocol to publish data and to share my results. This is a form of, I guess you could think of it as a form of data mining. So we're actually sort of mining the data from Google and trying to do some analysis on it. There are limits on query responses. It's stuff stored actually at Google, so I don't know how much data mining you'll be able to do. But there is the idea of being able to mine data sources on the web. There's also the sort of the boring, obvious stuff, which is administrative issues. Like, a lot of people just use it as a way of managing, say, the resources in a lab. You want to be able to, you can build your own tools, you can build your own web applications that will make your life simpler, make your system run smoother because you can integrate with all the tools. If you're using Google tools or other tools, you can integrate with them and manage things that way. And then also what we just said was like sharing your data and making it available to other people to use. There's an interesting application I put in here called Radish. I just thought it was a very cool example where somebody had come up with an idea that we hadn't thought of. So we created this calendar API, and our main thought has always been synchronization. And one of the engineers at Google said, well, now that all the conference rooms are on our calendar and they all have an API to the conference room schedule, I can put on each conference room a little device that electronically retrieves the schedule and displays it. So they looked at it and said, we're printing how many thousands of sheets of paper every day to stick in those conference rooms to say this conference room is owned by, this conference room is reserved every day. And they reprint those every single day, and we've got, 800 conference rooms. You can count the paper. And so somebody went ahead and built a little device. It's a little wireless device. It uses ambient electric light to charge itself. So it's solar powered. And then it has one of these electronic paper displays that requires no power when it's actually off. And so every once in a while, every couple hours or minutes, it wakes up, queries the GData API, figures out what that conference room schedule is, displays it, and then shuts itself down again and just sits there and soaks up ambient light. Takes no powered electricity. This is just, and he said, I just couldn't abide. The engineer just could not abide by wasting so much paper. And so he came up with a very novel new way to sort of exploit the fact that your data is available to do something to solve a problem that nobody had ever even considered, which was saving paper. So I really thought that was kind of a cool example. So, I just wanted to open it up to you guys. What do you guys think what do you guys think is ways that we could possibly use our APIs or possibly make that the exposing data on the web could be better, or things that you'd like to see us do? Or just questions about the APIs in general, of course. If you have technical questions about what we do or how we do it, this would be a good time. So
I was wondering if there's a way that you allow people to link into tools like Google Maps, for example, because the technology there would be great for some of us to, bring in. So I work on biological data, bring in our biological networks, then lay them out with Google Maps and things like that. Or are you keeping all of those completely proprietary?
Should we let Pamela take that one?
Oh, you guys, because
Pamela's the support engineer for Maps.
We do have a Maps API, but it's not.
When I'm not making games, my job is actually to support the Google Maps API. So I don't know if there's a talk about the Google Maps API today or not.
I don't think so.
Okay. So we do have APIs for Google Maps and Google Earth now. And so the APIs are really visualization APIs, so letting you easily create a map and then add data on top of the map. So we don't have any sort of geodata API, although we have announced that we're working on that. So calendar is like storing data that's specialized for storing time tag data, right? So we're going to have a geodata API, which allows you to easily store data that's geotagged. And then you can imagine that the queries that you do against that data would be stuff like bounding box search, radius search, stuff that's specific to geodata that you obviously wouldn't do on a calendar feed. So that's going to be coming out. We pre-announced that a few months ago. So we do have the geodata API coming out. Until then, you can use the Earth API if you want to control 3D Earth in the browser. You use the Maps API if you want to create your own 2D Maps mashup. And one other thing to point out is that we have a standard for geodata called KML, which has integrated with Atom a little bit, and will probably integrate more in the future, especially with this GData API coming out. So if you want to publish your format, so here this is publishing your data generally to be consumed by anyone. If you have geodata specifically, you probably want to look into publishing that data as KML. As KML is a standard that we started at Google Earth, but now is embraced by Microsoft, Yahoo, and a lot of different places. And there's like thousands of KML files on the web. So that's something to look into.
So yes.
Thank you. What is in place that could help serve for digital signatures, for knowing that the code is backed by someone that we can go back to, that we know that it's a legitimate version of something?
Are you referring to the code or the data, like the value of the value?
Well, actually, it could be done in both. I mean, you've got some libraries you're making available, and then you've also got the data that we can download. With things like cache poisoning, if we think we're downloading data from the map, how do we know we're really getting data from the map rather than something that's going to lead us off a bridge or into a restricted area? I have a number of issues like this where when you're passing a lot of things around as both feeds and as libraries, there are all kinds of opportunities to wreak mischief. And so this is an area of my concern in my research. Having some good digital signatures, having some trace back, some authentication measures would seem to be reasonable, and I'm just wondering who's working on that. What do you have available?
Well, for the GData APIs, I mean, I'm sure there are plenty of attack vectors. As you said, you can attack the client libraries, you can attack a lot of DNS, you can attack a lot of things. Basically, if you think of Atom Publishing Protocol and REST in general, it's a lot like working on any web problem. I mean, it's essentially we're not any different than anybody suffering from phishing, and we all know the problems that come along with those. We have, so realistically speaking, the GData APIs per se don't deal with a lot of those attack vectors. Those are probably things that need to be solved at a level. You need the mic? Those are things that need to be solved at a level below that. In terms of, I can't remember what else I was going to mention. But,
well, you never mentioned sub request signing. So
well, in terms of authentication, there are some issues. Well, one of the things that we do work on specifically is authentication, which is knowing that the person accessing the data is actually getting the data. So there is standards out there called Oauth, if you're familiar with OAuth.
Yeah.
And so for those of you who aren't aware, OAuth is based on the idea that I'm working with a website that wants to get access to my calendar information, or more commonly, actually, one of the more popular cases, my contact information. I want to give friend feed my contact information, and friend feed then wants to go query my API, but I don't want to necessarily give them. I want to give them the access rights, but I don't want to give them my username and password. So there's a standard now that's emerged called OAuth, where that website, friend feed, would redirect you to Google. You would log in at Google again, HTTPS, so we're relying on basic web security mechanisms. Google would then redirect you back to that website, and that website would receive a token that they could then use to access your service without knowing anything about it. So that's an issue. That's one issue actually we work on a lot, is authentication and authorization issues are one area where we do a lot of work.
But just as a quick follow-up to that, when you said it's similar to phishing, a lot of the ways that we can deal with phishing attacks and getting false pages is to have them digitally signed. So I guess really going back to the issue of, if I'm going to request data from your maps, or I'm going to send a selector that I'm going to ask for data that I'm going to bring in and then process, Google has a lot of computing power. And being able to put a digital signature on that data before it goes out, or calculate a message digest even, that I had some way of tracking back, would give me greater confidence that I'm getting the real thing, and that I'm getting something that was actually intended to be provided to me from Google. So as a suggestion,
I could mention that Atom, if you're familiar with Atom Publishing, Atom syndication format, the data format that we use, there actually are signing standards for signing the data items themselves. I don't believe that they've been heavily used in the web. So a lot of the Atom feeds that come out right now come out unsigned. But they do. But those standards do exist, and that they haven't been widely deployed.
Yeah. I mean, I think it's reasonable. We do have some APIs that just work over SSL, but since we have signed requests, we might as well have signed responses in the future if we want to look at that.
Yeah, we've looked at, well, like I said, I think where you'd probably want to go is with the Atom signature type mechanisms. I think one of the biggest problems with them was a lot of the idea behind the Atom signature, a lot of the idea behind some of the Atom was being able to republish information, like an entry would be a self-contained object, self-describing, you could then republish, but then the signature tends to get broken because of, it tends to depend on like source attributes that change. And
Depends on where you sign it, yeah.
it depends on how you sign it, right. So the signing actually became a very complicated problem, and a lot of people just threw up their hands and said, I trust that if HTTPS gets me to the source, I'm okay.